In this video, let's use SPI communication protocol to communicate between two Arduinos. So we are using SPI, which also stands for Serial Peripheral Interface Communication. And the objective is to demonstrate communication between a master and slave. In theory, the SPI communication, you can see it can have it's a synchronous communication, and it's a full duplex communication protocol. And you can see there is a one master and there could be multiple slaves over here. You can see it uses one clock from the master, and that is shared by all the slaves. You can see all the, and likewise you have one master out slave in data line. You can see that line is going to all the slaves. However, which slave should pick it up and read it, that the master tells or selects using the select lines. You can see there is a select line between master and independent select line to the slave. Likewise, you can see the select lines between the slaves. And you can see the slaves also can send back to the master. You can see the master in, slave out, the line going over here. However, which slave is to send to the master at any given point of time, the master controls it through the slave lines. That is how the connections are. And then moving on, in our experiment, what we'll do is we'll just use one master and one slave, Arduino Uno, and they'll be connected using SPI. So here in the diagram or the video link, you can see this is the master and this is the slaves, and we have these four lines over here. Four lines, all those the master in, slave out, slave in, and then the clock, and then the select line. So those pins they are connected from the master to the slave. And then coming to the jumper wires, the way we use the jumper wires, they're given over here. In fact, in Arduino, you can see the select line is pin number 10, master out slave in is pin number 11, master in slave out line is pin number 12. Likewise, the clock line is pin number 13. In fact, the ground, connecting the ground, this is optional. In the video, we haven't connected the ground. We have connected only these four lines. Then coming to the master code. So I have copied this master code, and in the background you can see I have this Arduino over here. Let me bring the video also to the side. And you can see we use the library SPI over here. No special libraries are required to be installed. By default, the Arduino will have it. And in the setup, you can see SPI begin, and then the pin mode SS, the select line has been configured as output, and then it is initially deselected. The slave is disabled initially, and then the border rate you have. And in the loop, you can see to the select line, now the select line is enabled, so that whatever is returned to the master writes now, the slave can pick it up. And then you can see the data that we are sending is 066, and then that has been transferred. Transfer the data, and then the received bytes has been picked up, and then you can see the SS is immediately disabled. And then using the USB, things are being printed over here, printed saying, okay, we send this data, and then we receive this data from the slave, and this is happening every 1 second. So this, what we'll do is we'll go ahead and we'll write this into the this is the master. So you can see the LEDs are blinking over here, and things are being uploaded to the master. So it has been uploaded to the master. Likewise, let's get back to the slave. So slave also has been connected. By the way, to the master, I'll show you in the tools, Arduino Uno, and port number 101 is the master. And likewise, if we go to the slave, port number 401 is the slave. In fact, to the same PC, my laptop, I have connected both the master and the slave. I have connected both of them. And in the slave code, if you look at the slave code, it uses again the SPI library. In the setup, you can see it has been, in fact, master in, slave out has been configured as output pin. And then this is about enabling the SPI to make it in a slave mode. So you can see this is bit, the bit inside that has been set over here. Likewise, enabling the interrupt also. So even that bit is set over here. Then there is this ISR subroutine that has been reserved. The slave works as in an interrupt mode. You can see in the loop, there is nothing in the loop. Only the ISR is there. So ISR receives a vector, you can see received bytes. In fact, is there in this volatile variable SPTR. And SPTR, now whatever you have received from the master, in fact, master will be sending 66, hexadecimal 66. Whatever he receives, the received data is incremented by 1. And then that is what is returned back using SPI. And now using the USB, things are being printed over here. You should say that I received 66, and you should be saying that I sent the received data plus 1. That is what I sent. So that is what should come. So let's go ahead. Let's also bring in the video feed. Let's bring in, yeah, here's the video feed. And then let's upload this code. So if you upload this code, you can see the code is being uploaded here. The slave has been configured. Both of them are ready. Now let's go and see the serial monitors. Let's open the serial monitors, and let's open the serial monitor of the master also. So here's the data being, you can see from the master is sending 66 and is receiving 67. It's going all the way to the slave over here. So slave is receiving 66 from the master, and yes, he's sending 67. Just to make sure that let's modify the code a little and do it on the fly. So for example, let me, instead of 66, let the master send 76. And then let's upload this code afresh now. We're uploading this code afresh. Now you can see immediately, you can see the master has sent 76. Slave is saying master sent 76, and he has he is received 76 and he sent 71. Likewise, the master also is saying that I'm sending 76 and receiving 77. So that's our objective. We are communicating. We have used SPI to communicate between one master and a slave. And like the other videos, if you want multiple slaves also, you can connect multiple slaves, and the master can keep selecting which slave he wants to communicate with. And this is a synchronous full duplex communication. So we have met our objective. I'll stop here.